Hello everyone, I am Isha Kumari from Sri Venkateswara College of Engineering, Bangalore from the Department of Computer Science and Artificial Intelligence, and here is a presentation of Principles of Artificial Intelligence. The topic is Intelligent Agents. So the outline: Agents and Environments, Rationality, PEAS, Performance Measure, Environment, Actuators and Sensors, Environment Types, and Agent Types. So, what are agents? An agent is anything that can be viewed as perceiving its environment through sensors and acting upon the environment through actuators. So, human agents. An agent is anything that can be viewed as perceiving its environment through sensors and acting upon the human agents are eyes, ears, and other organs for sensors, hands, legs, mouth, and other body parts for actuators. So, robotic agent, cameras and infrared range finders for sensors, various motors for actuators. So, agents and environments. Here is a pictorial representation. The agent function maps for percept histories to actions. Uh, and then the agent program runs on the physical architecture to produce F, rationality. So, performance measuring success, agent's prior knowledge of environment, actions that agent can perform, agent's percept sequence to date, then rational agent. For each possible percept sequence, a rational agent should select an action that is expected to maximize its performance measure given the evidence provided by the percept sequence and whatever built-in knowledge the agent has. So now rationality. Rational is different from omniscience. Percepts may not supply all relevant information. Example in card games, don't know card of others. So rational is different from being perfect. Rationality maximizes expected outcome, while perfection maximizes actual outcome. So now PEAS. PEAS, which stand for Performance Measure, Environment, Actuators, and Sensors. So must first specify the settings for intelligent agent design. Consider example the task of designing an automated taxi driver. Performance measure: safe, fast, legal, comfortable trip, maximize profit. So environment will be road, other traffic, pedestrians, customers. Actuators will be steering wheel, accelerator, brake, signal, horn, and the sensors will be cameras, sonar, speedometer, GPS, odometer, engine sensors, and keyboard. So then agent, part picking robot. Performance measure will be percentage of part in correct bins. Then environment will be conveyor belt with part bins. Actuators, jointed arm and hand. Sensors will be camera joint angle sensors. Then environment types. So fully observable, deterministic, episodic, static, discrete, single agent. Agent types. Four basic types in order of increasing generality. Simple reflex agents with state model, goal-based agents, utility-based agents, then simple reflex agent. Here is a pictorial representation of that. Then the function will be reflex vacuum agent, location status, returns an action. If status equals to dirty, then return suck. Else if location equals to A, then return right. Else if location equal to B, then return left. Simple but very limited intelligence. Action does not depend on percept history, only on current percept. Therefore, no memory requirement. Infinite loop. Suppose vacuum cleaner does not observe location. What do you do given location? Clean left of A or right on B. Infinite loop. Fly buzzing around window or light. Possible solution: randomize action. Thermostat. So chess openings, endings. Lookup table, 35 to the power 100 entries required for the entire game. So now model-based reflex agents. Here is a pictorial representation. So for model-based reflex agent, we should know how world evolves. Overtaking car gets closer from behind. How agents' action affect the world. Wheels turned clockwise takes you right. Model-based agents update their state. And here is a function for model-based reflex agents. Now coming to goal-based agents, knowing state and environment, enough taxi can go left, right, straight. Have a goal, a destination to get to. Uses knowledge about the goal to guide its action. Example, search, planning. So here is a picture of goal-based agent. Reflex agent brakes when it sees brake lights. Goal-based agent reasons. Brake light, car in front is stopping. I should stop. I should use brakes. So this is how reflex agent brakes. Now, utility-based agents. Goals are not always enough. Many action sequence get taxi to destination. Consider other things. How fast, how safe. A utility function maps a state onto a real number which describes the associated degree of happiness, goodness, success. Where does the utility measure come from? Economics, money, biology, number of offsprings, your life. So utility-based agents. Here is a picture of utility-based agent. Then learning agent. Performance element is what was previously the whole agent. Input sensor, output action, learning element modifies performance element. Critic, how the agent is doing. Input checkmate, fixed. Problem generator tries to solve the problem differently instead of optimizing. Suggests, exploring new action, new problems. So learning agent, taxi driver, how performance element, how it currently drives. Taxi driver makes quick left turn across three lanes. Critics observe shocking language by passenger and other driver and informs bad action. Learning elements tries to modify performance elements for future. Problem generator suggests experiment out something called brakes on different road condition. Exploration versus exploitation. Learning experience can be costly in the short run. Shocking language from other drivers, less tip, fewer passengers. So the big picture, AI for model-based agents. So action, learning, the knowledge. The picture for reflex-based agent, action and learning. Reinforcement learning studied in AI, cybernetics, control theory, biology, psychology. So the summary is agents can be described by their PEAS. Environments can be described by several key properties, 64 environment types. A rational agent maximizes the performance measure for the PEAS. The performance measure depends on the action function. The agent program implements the action function, the agent function. Three main architecture for agent programs. Thank you.